with adding integers. Now, just in case you've forgotten or didn't know, integer is a positive or negative whole number. Okay? No fractions, no decimals. They're just whole numbers, but they're positives and negatives. Okay? And there are rules for adding integers. If the numbers have the same sign, you add the numbers and keep the sign. So 2 negatives add up and make a negative, 2 positives add up and make a positive. If the numbers have different signs, you want to subtract the numbers. And you're going to keep the sign of the bigger number. And I'm going to put bigger in parentheses, or not parentheses, in quotes, because technically speaking, positive numbers are always greater than negative numbers. But I'm going to say a negative 10 is bigger. The 10 is bigger than a positive 2, right? Because 10 is bigger than 2, even though technically positive 2 is greater than negative 10. Does that make sense? So in that example, if I said negative 10 plus 2, I have a negative and I have a positive. I have opposite signs, so I'm going to subtract. So 10 minus 2 is 8. But because the 10 was bigger and it's negative, my answer is negative. Okay. Why is this like this? Well, because if you're adding or you have positive numbers, you're moving this way on the number line. And if you're subtracting or have negative numbers, you're moving that way on the number line. So if I start at negative 6 here, and I add a negative 2, I need to move 2 spaces this direction because that's the negative direction, which brings me to negative 8. So negative 6 plus negative 2 is negative 8. Why the parentheses? Because you don't write 6 plus minus like that. It's confusing. So the parentheses on the second negative are just to clarify that it's a negative number. Get rid of that because it's ugly and we don't like it. We like to look at things in different ways. I can look at this like money, right? If I have $9, but I owed $6. Negative is money you owe. Positive is money you have. If I have 9 but I owed 6, how much do I have left? Right, $3 left. So 9 plus negative 6 is 3. So you can think of it money. Money is a nice way to think of it because you guys know money. Another way you can think of it is negative 4 is the same thing as 4 negatives. And negative 3 is the same thing as 3 negatives. How many negatives do I have? 7 negatives. Now what happens if I have positives and negatives? Well, I have 17 negatives. Right? And then I have 5 positives. And every negative and positive will cancel each other out. So 1 negative and 1 positive will cancel, which leaves me 12 negatives left. So negative 12. This is just different ways to think about it if the rules don't quite work for you. Now subtraction, I'm calling it also known as addition by another name. Technically speaking, subtraction doesn't really exist. You're just adding positives and negatives. But, you know, remember subtraction in elementary school? We did 9 minus 6 is 3. Cool, easy, nice. We liked it. And that's great if the both numbers are positive and the second number is less than the first, like this. But what if I had 6 minus 9? Didn't teach you that, right? Well, we also could have a situation of negative 6 minus 9. Like, it's confusing, right? If you look at it the way you've learned subtraction, this is, like, you don't even know what to do with that. You know, if it was 16 minus 9, then you need to borrow from the 1 and all that, but we don't really do that here. So here's how we would work those out. Okay, what we do, the first thing when we're subtracting integers is we're going to change the problem to adding the opposite. Okay, and the opposite of a positive is a negative. The opposite of a negative is a positive, right? Negatives and positives are opposite of each other. So we're going to change the problem to adding the opposite, and then we're going to follow the addition rules. Okay, so that example I had, 6 minus 9. That is the same thing as 6 plus negative 9. And then if I follow my addition rules, I've got a positive plus negative, so I'm going to subtract. The 9 is bigger, so it's negative. If I have negative 6 minus 9, that is the same thing as negative 6 plus negative 9. These are two negatives, so I'm going to add them together. So that's 6 plus 9 is 15, so this is negative 15. Now, do you actually have to write this like this? You don't have to, no. But this is how I want you to think about it. So when you see this, you're thinking negative 6 plus negative 9. Or if you see this, you're thinking 6 plus negative 9. So that it helps you to know what to do. If it helps you to rewrite them, then rewrite them. If you don't need to, you don't have to. But this is kind of the same thing, that 6 negatives, 9 negatives, gives me 15 negatives. So we don't really think of subtraction anymore. We don't really think of minus. We think of negative. This is like negative 6 and negative 9. Well, negative 6 and negative 9 gives me negative 15. Does that make sense? Okay, so multiplication and division, they're not the same, right? Multiplying is one thing and division is another, but the rules are the same for both. That's why it's the same but different. So the first rule is if the signs match, your answer is positive. If the signs are different, the answer is negative. Okay, so some examples. 6 times, oh no, I'm doing the big 6 times negative 3. Okay, we don't use x's for multiplication anymore. This is multiplication. I can also write this as 6 times negative 3, like that. Okay, but we don't use the x anymore. So 6 and negative 3, opposite signs, so my answer is going to be negative. Negative 6 times negative 3, same sign, answer is positive. 6 divided by negative 3, negative. Negative 6 divided by negative 3, positive. Negative 6 divided by positive 3, negative. So like, okay, what's up with Aunt Sally? In other words, we want to talk about the order of operation. And order of operation simply means the order that you perform math in. Okay. Now, there's two very famous ways to remember the order of operations. The one that we learned when I was a kid was please excuse My dear Aunt Sally. Okay, please excuse my dear Aunt Sally. Now people use PEMDAS. They both mean the same thing. So you see PEMDAS. And this is the order of operations. And let me see, I've forgotten what order I put things on. Yeah, okay. So what this means is you do everything in parentheses first. Now this is not just parentheses, it's any grouping symbol. So it's parentheses, brackets, braces. Okay, brackets are like that. Braces are like this. It can also be anything on either side of a fraction bar. That's what the line in a fraction is called. It's called a fraction bar, and sometimes you'll have like addition on top of a fraction bar and subtraction on the bottom. So you do that first and then you do the division. So any grouping symbol. Then the second thing you do is exponents. And then the third thing you do is you multiply or divide. Okay? And this is something that gets messed up. Sometimes people think you have to multiply first and then you go through and divide. But you multiply or divide whatever one comes in order first. So whichever one is first as you move left to right, the same direction you read. Okay? And then the last thing you do is add or subtract. Again, whichever one comes first as you move this way. Okay, and now I like to think of it this way. Parentheses are the king, exponents are the queen, multiplication and division are the prince and princess, and addition and subtraction are the peasants. This is their order of importance, right? The king is more important than the queen, who is more important than the prince and the princess, and the peasants are down here at the bottom where nobody cares about. Here's a good one that some 7th graders came up with. Purple elephants munch daisies all Saturday. Right? Purple elephants munch daisies all Saturday. You make up your own phrase. Anything that'll help you to remember, just as long as you remember the order. You can use PEMDAS, you can use please excuse my dear Aunt Sally, you can make up your own phrase, anything you want. Just so long as you remember the order. And the reason we have this is so that if I give you guys a math problem and I email that same math problem to students all over the whole world, you should all get the same answer. Because you should all do it in the same order and in the same steps. And the order does matter. For example, wait, not that one. That won't work. Never mind. Hold on. Let me write a problem that would actually work. If I do the addition first, I'll get 9 divided by 2. That's 4.5, right? Or I can do 3 plus 6 divided by 2. Well, 6 divided by 2 is 3, so 3 plus 3 is 6. Completely different answer. So the order makes a difference. Okay? So, yeah, 3 plus 6 is 9. 9 divided by 2 is 4.5. Not good. But 3 plus 3, 9. That's the correct answer. So just, it does make a difference. Okay, so you do this part first and then that part second to get 6. What do I do first? I'm going to do 5 times 4 first, and then I'm going to add, right? So sometimes I do this, like I'll put an arrow for the part I do first. So this is 10 plus 20, and then 10 plus 20 is 30. I don't like to use equal signs a whole lot when I'm doing things like this because I want to kind of keep equal signs for equations, and this is not an equation, this is just an expression. But if you put an equal sign, I'm not going to count it wrong. What do I do first here? Yeah, so I'm going to do that part first. So 24 minus 3 squared. So what do I do second? Exponents. So it's going to be 24 minus 9. And 24 minus 9 is, whoops, I'm going to put my arrow, 15. Okay. First, parentheses. Now, when you have something like this, I have a parenthesis and I have an exponent and they're separated by addition, I can kind of do those at the same time because they're not affecting each other. So technically I did the parentheses first and then I did the exponent. But that'll save you having to write 2 separate lines if you want. What do I do next? And then addition. Okay, but it doesn't have to be like that's a lot, right? That looks like a lot that's going on. Okay, so here's another chart. But let's look at this problem. If I do 3 bracket negative 2 parentheses 5 minus 6 exponent 2 minus parenthesis 5 minus 6 bracket. Okay, what you want to do is you want to start on the innermost parentheses. Okay, so I'm going to start in here. So I'm going to do these parentheses first. Okay, so I have 3 bracket negative 2 parenthesis 5 minus 6 negative 1 squared minus negative 1. Okay, now I'm going to work inside the brackets. And the first thing I need to do inside the brackets is square this negative 1. So I'm going to do that. And everything else, I'm just writing exactly how it is. Negative 1 squared is positive 1. Okay, then the next thing I want to do is minus a negative. Yeah, here's a nice way to think of it. If I have minus, doesn't he look happy? Doesn't it look like a little happy person right there? Or you can connect them to make a big plus. But whenever you have minus parenthesis minus, it ends up being a positive. So this actually is the same thing as this. Negative 1 times 1, or negative 2 times 1 is negative 2. Negative 2 plus 1 is negative 1. So we did all of that, and it's just negative 3. So when you see big, long problems like that, don't get caught up in the giantness of it. Take it in little, small pieces at a time. Because each one of those little steps that we did was fairly simple. It just looks really complicated. Does that make sense?